we made mention categorically that if you are doing reflection in the x-axis, xy becomes x negative y, which means that it is the x that is maintained whilst the y becomes negative. And we said it's also called reflection the line y equals 0. Then we also said if you are doing reflection in the y-axis, what is going to happen is the reverse of the x-axis. So xy becomes negative xy. When we said you can reflect in the line x equals a, you also call x equals 0. So if x equals a, I reflecting in that line, xy should become 2a minus x and then the y. Write these formulas down. Then we also saying reflection in the line y is equal to a. That one to xy becomes x is the same, then you have 2a minus y for the y part of it. Then we have reflection in the line y is equal to x. We said that one, if y is equal to x, and it means that x is equal to y. So x becomes y, and then y becomes x. So we can also have y is equal to negative x. In that case, if that is the case, x becomes negative y, and y becomes negative x. Are you okay? Are you okay?
Yes.
If you've not written it down, write it down so we take the next one. Rotation. Then we'll start answering the graph questions soon. Or let me take translation first. So for translation, you wouldn't have a problem because if you're having a point, let's say A, and you are translating, it will translate by the vector. So if my vector is AB, and I'm translating the point A, what I have to notice, I have to add the point to the vector xy plus the vector AB, and that should give me the image. So if I want the image of the point, I only have to add the point to the vector. So in that addition, what happens is that I add the x components and then I add the y component. So if I do that, I'm going to get the image of the vector. So in a nutshell, for translation, we are saying that points plus translation vector should always give you the image. So in that case, if you want the translation vector, it's going to be image minus the points. Or if you want the points, it's going to be image minus the translation vector. So keep these formulas in your minds so that it can help you to solve questions. Do you understand?
Yes.
Okay, so let me go to the next one. Cycling. Rotation. So in line with rotation, rotation is only possible about a fixed point. So if you are rotating, it means that you are turning about a fixed point. Okay. So for the rotations, the fixed point determines how the thing will turn. So in most cases, our fixed point is the origin. If our fixed point is the origin, then we can do our rotation very easily. How do you understand rotation? I'm showing you how it works for the formula. If this is your normal graph, what you see here, the x side of this is positive, and the y upwards is positive, and the left of it is negative, and the downwards is also negative. So if you want this region, the x side of it is positive, if you can see clearly. The x side is positive and the y side is also positive. So here we have positive x and we have positive y. What in this region? Where I've ticked the blue. The x side there is what? Negative. And the y is the top, which is what? Positive. So I'm going to have negative x, negative y. If you come here, down here too, the x side here is negative and the y side is also negative. I'm going to have negative x, negative y. And that is also my point there. So the last point, what do you think it will be?
X, Y.
XY is wrong.
X negative Y.
Good. X negative Y is correct. So now, this is the normal graph that we have. If we are doing rotation, what is happening is that rotation would only happen where the X and the Y will be interchanging positions. So it should start from somewhere. Where should it start from? The right-hand side. X is positive and then y is also positive. When we come here, the x and y will interchange position. So whereas the x is at the top and the y is down, the negative will still be at the top, but the y will come up and the x will come down. That's negative y with x. When you come down here to the y and the x will still interchange from yx back to xy, which is the same as the original here, negative x, negative y. So when we come to this side, the x and the y will interchange. So the y goes up, the negative is still down, and then the x comes there. So that becomes y negative x. We now have what I have. The next is I know that if I make the movement towards my left, like I have done, see this, the movement is towards left side. And take a look at the green one. The movement is towards the right side. So if the movement is towards the left side, like the red one, we call it anti-clockwise. And if it is towards the right, we call it clockwise. The green is clockwise and the red is anti-clockwise. So if I am here and I come here, that's 90. So this is 90 clockwise. If I come here, it is 180 clockwise. If I come here, it is 270 clockwise. If I go here, it is 90 anti-clockwise. If I come here, it is 180 anti-clockwise. If I come here, it is 270 anti-clockwise. So what it means is that if you want the formula for 90 clockwise rotation, the xy, which is the original, will become y negative x. If you want the formula for 180 clockwise, it is negative x negative y. If you want the formula for 270 clockwise, it is negative y x. In the same vein, if you are going towards the left, that's the red one, anti-clockwise. So 90 anti-clockwise is negative y x. 180 anti-clockwise is negative x negative y. 270 anti-clockwise is y negative x. And that is how it works. Any questions so far on the rotation?
The teacher is wrong.
The
No, if the line, how you rotate or strong.
How?
No, that's it. Arrows to that line.
I can't hear
Oh,
you.
yeah. How?
Are you okay?
In Ghana.
Are you okay?
Yes, please.
Okay.
So please, if we change it to anti-clockwise, that means the variables will move.
No, it's the same formula. It's just the movement that will change. So you see, if I have XY here, and I'm going towards this direction, that is 90 anti-clockwise. If I'm going toward the direction, that is 270 anti-clockwise.
Okay, sir.
So 90 anti-clockwise and 270 anti-clockwise is the same. You understand?
Yes, please. Now we may continue.
Okay. Now,
We close.
I'm okay.
okay. So the next thing we have to do is all of these ones are rotations about fixed points. That is the origin. So if you are rotating about the origin, this is what you do. But if you are rotating about a fixed point, which is not the origin, then I have termed it SRA. Use the SRA. Where with the SRA, we have subtract for the X. We have rotate for the R. Then we have add for the A. What it means is that you have to subtract, rotate, then you add. Subtract, rotate, add. So what does the subtract means? The subtract simply means subtract the point where you are rotating at from the point you want to rotate. So the point you want to rotate minus the point at which you are rotating. Okay. So if, let's say, I have point A, 3, leg 4, and I want to rotate this point 90 clockwise about the point leg 2, leg 3. So the point at which I am rotating A3, leg 4 is leg 2, leg 3. So the first step is saying, let me subtract that point from the point I want to rotate. So 3 neg 4, that's the point I want to rotate, minus the point at which I'm rotating, which is the neg 2, neg 3. So what does this subtraction amount to? 3 neg 4 minus negative 2 neg 3.
1 next 7.
That's not right. 3 minus minus 2 becomes 3 plus 2. Note that.
5 7.
Minus 3 is plus 3. So that's neg 4 plus 3.
7.
Neg 4 plus 3.
7.
Neg 4 plus 3.
Negative 1.
Negative 1.
Ah.
So it means that my answer is 5, negative 1. So if you now have 5, negative 1, now what's next? The next thing is that you rotate. Rotate 5, negative 1. It's 90 clockwise. What's the formula for 90 clockwise?
Y negative X.
So y negative x. So what's the y in 5 neg 1?
Y is the 5.
So y is the down
Y is
one.
negative 1.
X is the 5. So y will come first. So it means that negative 1 will come first. And then the down is negative x. So negative. What's the x? 5. So that one to give you negative 1, negative 5. Is that okay?
Yes.
So after rotating, the last one says add. So add the points, that's neg 2, neg 3, to your results. So what's neg 1 plus neg 2? Neg 3. Neg 5 plus neg 3. Neg 8.
8.
So it means that your image is now neg 3, neg 8. So in this case, if you are rotating at a point which is not the origin, then you have to subtract, rotate, then you add. Is that okay? Is that okay?
Yes, please.
Yes, please.
Okay, so let's go to enlargement. Everything we are going to learn in our next lesson, we are going to apply it and use that to solve the graph question. But I want you to start. At least do the first 2 tomorrow. Apply whatever we have done to solve the graph questions I sent. Do the first 2. So enlargement. So for enlargement, you always have to multiply the point by the scale factor. So if your scale factor is, let's say, k is 2, and you want to find the image of A, and the enlargement is about the origin, what you now have to do is multiply the 2, 3 by the scale factor 2. So 2 times 2